We humans come in a variety of different colors: white, brown, yellow. But why? Have you ever wondered from where does these colors come from? Remember all those school lessons that you learned about light and heat? About how black color absorbs more heat and you should wear white in summers because that reflects more heat. So, logically, you would think that people living in the hottest of areas would have the lightest of skin colors, right? But look around, the sunniest parts of our planet are home to the darkest skin tones. What's going on there? The answer lies in the sun rays. See, the light that we see is only a tiny portion of a much wider spectrum of electromagnetic radiation. The key characteristic of light that defines where it is on this spectrum is its wavelength. And the light coming from the sun is a mixture of these radiations of different wavelengths. This is the blackbody spectrum of the sun. It tells us about the relative proportions of different wavelength radiations that the sunlight is comprised of. As you can see, in addition to the visible light, sunlight is also comprised of infrared as well as the ultraviolet radiation. IR, or the infrared, is commonly referred to as the heat waves, and the heat that we feel from the sun is this infrared radiation. This infrared radiation, or the heat waves, is invisible to us as it lies outside the visible spectrum, and it is what we are talking about when we say that a black t-shirt absorbs more heat or radiation than a white one. But there is another player in the game, the ultraviolet radiation, or UV. UV, just like IR, is also invisible to us, but you can see its effects on your skin. It is the culprit behind tanning and sunburns. Rays of UV radiation are of higher energy than visible light, and these UV rays can lead to various problems like skin cancer, cataracts, and other eye damages, immune system suppression, premature aging of skin, and more. To protect against these harmful effects of UV, we developed a natural shield in our evolution, a pigment in our skin cells. This is melanin, your body's natural sunscreen. The more melanin you have, the darker your skin, and the more protection you have against UV's harmful effects. This is particularly important for a molecule called folate. This molecule is essential for healthy babies and sperm. Folate is needed for DNA synthesis, and UV rays can destroy folate levels, ultimately leading to various birth defects. In harsh sun regions, high melanin levels were a lifesaver, not only against the risk of skin cancer, but also towards protecting our ancestors' reproductive success. But UV is not all that bad either. Otherwise, we all would have higher levels of melanin by evolution. We actually need some UV as well. It stimulates the production of vitamin D, which is essential for strong bones and a healthy immune system. Skin has to be dark enough to protect folate levels, reduce the risk of skin cancer and other harmful effects, while light enough to create vitamin D. This is a world map overlaid with a UV index, and this is the skin color distribution of indigenous populations across the globe. These maps show the strong correlation between UV intensity and the skin color of various indigenous populations across the globe. So it is a balancing act. Near the equator, intense UV favored darker skin for protection, but further away, like up north in Europe, less sun meant the evolution of skin tones with lower melanin levels to allow enough UV light in for the production of vitamin D. Of course, it is not just about the latitude. Altitude, cloud cover, and even diet play a role in skin tone evolution. To conclude, the skin color is not just a shade difference. It is a story of survival, a testament to the incredible adaptability of the human species. Our skin is a living tapestry woven by the sun's rays and our ancestors' journey on this planet we call home.